Hey guys, in this video we're going to talk about operations with radical expressions. So, how do we add and subtract radicals? How do we multiply radicals together? A lot of stuff. Now, when we're adding and subtracting radicals, the number one thing you have to know is that the radicals, or the radicands, must be alike. They have to be the exact same. If they're not, you can't do anything. So take this first example. I have 4 root 5 plus 2 root 5. They both have square root 5. Since they both have that, I can add them together, and I add my outside numbers together. Okay, so 4 plus 2 is 6. Now my radical just kind of tags along. If they both have the same radical, it just kind of tags along and then sticks at the end here. This is the exact same logic as if you had 4x plus 2x. Alright, they both have x, which means I can add them together and get 6x. Okay, notice my x just kind of tagged along the whole time. Same thing with the radical. As long as your radicals are together, then you can add and subtract them, and the radical just kind of tags along. Example number 2 is the same thing. They both have a square root 3. Therefore, I can subtract my outside numbers and get 7 root 3. Now, what you could not do is if I had, I'll do this in red so you can see this is an example. If you had 4 root 5 plus 2 root 3, those could not go any further because they are not the exact same radical. It would be the same thing as trying to add 4x plus 2y. Okay, you can't add those two together because they don't have the same variable. All right, let's practice. Now for this first one, first thing you got to do is check and make sure you have the same radical. Square root 2, square root 2, so we're good. We can go ahead and we can add our outside numbers together. So 5 plus 3, 8 square root 2. Go to the second one. This is a square root 10, so we're good. Now I have 3 minus 3, which means our answer is going to be 0. Okay. Because 3 root 10 minus 3 root 10 would be 0. Now, in both of those examples, the radicals started off as the exact same. However, not all radical expressions are going to have similar radicands. What this means is you may have some expressions that can't simplify, and then there may be other expressions which you have to do a bit of simplifying first. Okay, so as we look down at this example down here, I have square root 18, 2 square root 18, 2 square root 32, and then the square root of 72. Now I do want to point out that just because they have the same 2 up front does not mean they are like terms. Okay, what matters is the radicand. Now none of these radicands are similar. They're not the exact same, but I can break all these radicals up. Okay, so what I'm going to do is I'm going to simplify all of these radicals as far down as I can, and hopefully, once I'm done simplifying, it will give me the same radicand. So we have 2 square root 18. That breaks up into 2 times the square root of 3 squared is 9, and then times the square root of 2. Then we have 2 square root 32. Get this one over here. And then last but not least, the square root of 72 is this one over here. Now what they did is they put 3 squared instead of 9, 4 squared instead of 16, and then 6 squared instead of 36. So they immediately went to the perfect squares. If you didn't automatically know that, it's fine. You would just break it down and then you would look for radicals that multiply by themselves. Because, as we know, if a radical is multiplied by itself, the radical goes away and only the inside number is left. So this, my red one, would simplify down into 3, into 3 square root 2. Okay, square root of 9 is 3, so it becomes 3, and the square root of 2 tags along. Notice how my 2 that was out front the whole time stays out front. And then the same things happen with the other ones. The 4 comes out, the square root 2 tags along, my outside 2 stays outside. And over here, 6 root 2, square root of 36 is 6, and the other square root 2 adds along. Now, if you're looking, you should be getting pretty excited right now because I now have a square root 2 in each term. But before I can add them together, I have to distribute my 2's that are out front. So I'm going to distribute this 2 inside, and I'm going to distribute this 2 inside. Okay, then my green term doesn't have anything that needs to be distributed, so it just comes straight down. And that's how you get 6 square root 2 plus 8 square root 2 plus 6 square root 2. They all have the same radical, so I can add up my coefficients, 6, 8, and 6. And my answer would be 20 square root 2. Now the number one thing in a problem like this is to keep your work organized. If you have different colors, go for it. But what you can't do is you can't forget your coefficients. So these 2's that were up front, can't forget those. And then you can't forget to bring down the radical 2 that doesn't have a partner. All right, let's practice. Okay, so this first one, I'm looking at it and I notice that I don't have the same radical. So we got to go ahead and we got to break down those radicals. I'm going to use red for my first term and I'm going to use blue for my second term. All right, let's do the first term. So I have -3, and then I can break up my radical 24 into radical 4 times the square root of 6. Okay, now I picked 4 and 6 because I know that 4, the square root of 4 is 2. So that's going to simplify nicely. All right, let's move on. Now I have -2 times, now 54. This is the square root of 9 times the square root of 6. Okay, I picked this one because I knew that 9 was a perfect square. And the added bonus is I now have a square root 6 in both terms. Okay, that's good because that means I could potentially add these together at the end. So now I'm going to simplify further. My coefficient comes down. Square root of 4 is 2. Square root of 6 just tags along. -2. Square root of 9 is 3 times my square root of 6. Okay? And this is looking good because, again, I still have my square root 6's in both. So now the last thing I have to do is just distribute my coefficients. So now I have a -6 square root 6 minus 6 square root 6. My answer is -12 square root 6, because a -6 plus a -6 is -12. All right, let's do one more. You're eventually going to do this one on your own, but I'm going to do the example number 2 with you. All right, here we go. Again, I'm going to use the same color scheme. That way you can see how the individual pieces are changing. If you want to pause right now and see if you can do it first, that'd be a good idea. All right, so I'm going to bring my, I'm going to look at it first. So I see square root of 3. The square root of 3 can't simplify any further. That's as far as it goes. So I'm just going to bring that one straight down. There's nothing more I can do to that one. Now I'm going to go to the back. -3 times. Okay, so here's where you get a little bit of strategy. I know I have a square root 3 up front. Okay? So if I can find a factor of 3 and 12, that will help me in the end. And I do know that 12 is the square root of 3 times the square root of 4. Okay? This is great because the square root of 4 is 2, and that will leave a square root of 3 for the next step. All right, so I'm going to bring everything down. To square root 3 comes down since it doesn't do anything yet. My coefficient comes down. The square root of 4 is 2 times the square root of 3. Distribute. Please don't forget your signs. Signs are very important. Okay, so that means I now have this negative 2 square root 3 minus 6 square root 3. That worked out nicely. And now I get negative 8 square root 3. Okay. Alrighty, you guys, it's your turn. Go ahead, pause the video, do this one. And here's your answer. Again, I did it color-coded so you can see what happens. Okay, and I picked my factors inside the parentheses because I knew they would be perfect squares. So I picked square root of 6 and square root of 4 because I knew square root of 4 was a perfect square. Okay. Now, as you can see, at the end, I have negative 2 square root 6 minus 8 square root 5. Okay, the reason why this cannot go any further is because the square root of 6 cannot add to the square root of 5. They are two different radicands, therefore they cannot combine. But as you may have noticed throughout the problem, the blue term and the green term did have the same. Okay, it ended up the same radicand. It ended up with 6 square root 5 minus 2 square root 5. So because those had the same term, I could add those together. Now, multiplying radical expressions. We've already done a little bit of this when we were in class, when we were simplifying the radical and rationalizing the denominator. So this should sound a little familiar to you. If we were multiplying variables, so radicals are very similar to variables. They have to be like terms, and they do similar jobs. So if we were multiplying 2x to 3x, you would multiply your numbers together, and that would give you 6. And then you'd multiply your variables together, and that would give you an x squared, because x times x is x squared. Oops. Well, when we go and we do radicals, same process applies. Okay? What we would do is you'd multiply your numbers together, or as I called them in class, your outside numbers together. 2 times 3 is still 6. And then you'd multiply your inside numbers together, or in this case, the inside variable. We have a square root x times a square root x. Anytime you multiply a radical by itself, the radical goes away and you're left with the same inside number. Okay? This is basically the distributive property. So here we go. What I'm going to do is every single time I'm going to multiply my radical. Remember, outside numbers go to outside numbers. Inside numbers go to inside numbers. Okay, so when I multiply this first one, I'm going to multiply the square root of 5 to the square root of 6. And these are both inside numbers, so I can put them together. This gives me the square root of 30. Now I'm going to go to the square root of 5 over to 3. 3 is an outside number, so it has to stay outside. And the square root of 5 just tags along. Okay, this is as simplified as I can get because 30 doesn't have any perfect squares inside. Okay, let's do another one. You're eventually going to be doing this one, but I'll do the second one with you. So here we go, number 2. I'm going to distribute to the first term. Now on this one, I have an outside number and a radical. So outside numbers to outside numbers, inside numbers to inside numbers. 2 and 2 are both outside numbers, so they can be multiplied together. And then my square root 3 tags along. Plus, over here. There is no outside number, so my 2 tags along, and it just stays out front. But now I have the square root of 3 times the square root of 3. Any radical multiplied by itself gets rid of the radical, and so now I have times 3. I can simplify that number, so I have 4 radical 3 plus 6, and this would be my final answer. Okay? All right, your turn. Go ahead. Video's going to pause. Do the next one. How'd you do? All right, so on this one, the first term should have been fairly simple. 2 square root 15 times 5. 5 is an outside number, so it gets multiplied to my outside number of 2, and I have 10 square root 15. And this 10 square root 15 just kind of tags along throughout the whole problem. Then you had 2 square root 15 times 5 square root 3. So my outsides multiplied together and I got 10. So 2 times 5 gives me 10. Then I have my two inside numbers of 15 and 3. Now I just put them under the radical together. The reason why I did that, and hopefully you did it too, was that I knew I could break 15 up a little further. Okay? It did me no good to break it up in this first term because 5 times 3, neither one of those comes out. But in this back term, I might be able to do something. And so I broke 15 up into square root 5 times square root 3, and then my other square root 3 tagged along, and that's when I saw that I had 2 square root 3's. And anytime you have a radical times itself, that number comes out. Okay, and that's how I got 10 times 3, square root 5. And this would be your final answer. We'll go over this more in class. If you have any questions, please mark them and let me know in class. Have a good one.